Welcome to the DeviceDojo. I'm Joseph, and this is where we tackle the practical side of securing connected devices, from over-the-air updates and fleet management to the broader challenges like incident detection and response, compliance, encryption, and more. Always actionable and hands-on, brought to you by Northern Tech, makers of Mend.io. And let's get started. Yeah, I definitely should record this because if you get a reading hiccup right in the opening, that's just like ridiculous. But you know me, that's what happens if you listen to me. So, what do we want to talk about today? Fail2Ban. And most of you will probably have heard that in some server side or SSH context. And I actually think that it's a really, really cool strategy or tool to help secure your connected devices. And let's look at how that is. So, just a short reminder about the DeviceDojo. This is a series presented by Northern Tech. This is the company behind Mend.io, Alvaldi, and CF Engine. They sponsor doing this stuff to just help you secure your connected devices. I'm just getting started with all of this. So the first couple of sessions are still very hands-on about tutorials. But in the future, I'll also provide live coding and office hours and things like that. So please follow the channel on YouTube, follow me on LinkedIn and all of this stuff so you get notified whenever something hits my mind. And here's today's agenda. I want to explain a little bit about possible custom applications in connected devices. From there on, the importance of logs, how Fail2Ban uses them, how Fail2Ban can act on them, and then a really short demo, which hopefully does not explode today. And after that, you can tell me that you liked what I did, or you didn't like, or whatever else. As usual, please drop me any kinds of comments in on YouTube, on LinkedIn, whatever. I'll try to answer everything as live as possible. Those of you who have ever seen me before, I like my sessions to be really, really interactive. Okay, custom applications. If you are making a connected device, then chances are that whatever its function is provided as a form of application. Let's call it application. It can be like a control algorithm or a human interface to something web front end or whatever. And if for whatever reason this kind of your application does not have any kind of inbound open port, then you can just like lean back or grab a coffee and skip the rest of this session because then nothing applies to you. Happy you. Otherwise, I think you should know a little bit about dealing with that stuff. So what we want to talk about today is a way to protect your application from incoming malicious attempts. Let's call it like that. And incoming means you have something open to the outside world. The most prominent thing here is a web frontend, obviously, and a lot of embedded devices have those these days. It can be like a configuration front end that people can use on their local networks. A very prominent example here are the configuration front ends of Fritz boxes or web routers or whatever. But it also can be like a management front end where you can upload some form of software or assets. It can also be application endpoints, and here where it gets interesting, that are used by like an application on your mobile phone or an application endpoint that is used within the web application and things like that. So just because you have a web front end, it does not mean that you don't have anything else, because that web application usually pulls data from some form of endpoint, of HTTP, REST, whatever, and that should probably be protected too. And the less prominent, but nonetheless very, very important ones are debug logins. Nobody admits them, but they are there, like a remote terminal, SSH terminal hidden somewhere, or even IPC mechanisms. If your device is able to form a kind of mesh in a local network, like discovery of similar devices, and then they have a common configuration surface or things like that. This obviously means that there is a form of discovery and inbound application too, inbound connection possibility too, and this obviously is also something that can be attacked. So whatever is listening on your device, if you have it, be prepared for it being attacked to a certain extent. More if you are on the open internet, less if you are only in firewalled custom networks, but nevertheless, it's there. And the first step that you need to take is logging everything that is unexpected. You can and probably should go one step further and logging expected things too. And a very, very good example for this is auth log on whatever Linux you're running. This logs whatever you do on sudo. If you happen to use an Ubuntu or Debian derivative, whatever happens on SSH logins, whatever happens on cron, things like that. It's all there. And your application really should do something similar. That's my take on it. Let me just click one fancy banner. If you feel like I'm doing something wrong or right or whatever, let me know on the banner up. And here's a couple of ideas that you should log. Obviously, logins. I mean, somebody opens the web front end, tries to log in, and fails. This is the bare minimum. If this happens, log it, including the source IP. If you have only one thing that you can log, this is it. The next things are also logging successful logins. And after that, we get a little bit more creative because your endpoints probably expect some form of data structure, like specific headers, a specific body, be it JSON or XML or whatever. And whenever something arrives there that you do not expect, then A, your application needs to handle it gracefully, like saying, okay, no, this is not what I expected. I'm not going to react on this. And you also should log it. Because where could such a payload come from? Your application, we expect your own counterpoint to be well behaved. So if something really, really else arrives, then there's a really high chance of that being an attack, or at least kind of like poking if there's something that people can break there. So my suggestion is to really log everything. If something malformed arrives, put it into the log. If somebody tries to upload a file in a file type that you totally don't expect, log it. A very common thing here are uploading JPEGs, for example, for some customization of the UI, whatever. So whenever somebody tries to upload an exe file or an archive, hey, I think you should raise a flag. If it's just like a mishap by the user, they will just do it once. There will be one log in the one line entry in the log. Nothing bad happens. But if they try it again and again and again, this is where you should get curious. Or oversized files. There might be an attempt to write beyond what your application can handle to make it crash. So be aware of that. And if it happens, then log it. IP XXXXX tried to upload 150 megabytes file where your application only expected like one image. Nobody uploads such a thing randomly. So if somebody does it, then they are probably trying to attack your device. Again, log it. And SSH is the most prominent application, I would say, to be attacked in such a context, and everybody knows about it. And my pitch here is to say, hey, let's take the approach that you use for SSH and use it for your custom application. And the approach is Fail2Ban. Fail2Ban is usually referred to as an intrusion detection system. It's referred to as an intrusion prevention system. I really don't care what you call it. But in the end, it looks at a log file, and if a number of bad things or suspicious things happen, then the IP gets banned. And usually it's SSH login attempts, because if you put a public server out on the internet, it will get hammered by SSH login attempts, and Fail2Ban then says like, hey, you tried it for 5 times in the last 10 minutes. I'm going to ban you. And this is the core usage, and hence the name, Fail2Ban. Now, let's get on how this actually works. Some kind of application, probably yours, or SSH, or Apache, or whatever, runs and produces a log file. Based on this log file, Fail2Ban can use a so-called filter. Filters use basically regular expressions to define whatever condition you have in that log. So here's the first pointer. Make sure that the format inside your logs is somewhat, I don't want to say structured. Structured is like is a word for business people or for cloud people. Hey, we've got structured logs. Yeah, it's okay. What we need is a form of consistency, just good enough to write a proper regular expression for it. Oh, and I also have a banner for this is what we're talking about here. Once such a regular expression filter passes or matches a number of attempts, then Fail2Ban kicks in. And in the most common use case where it comes from, Fail2Ban bans the offending IP that you can pull out of the logs. And that's why I said, hey, always log the source IP by setting a firewall rule. This means you need to have a firewall on your device. And this is also why I'm just going to demo it on a regular host today. And this is the most common action. That's why you usually define, hey, ban this port, or ban HTTP and HTTPS ranges, ban blah, blah, blah. But there's nothing that keeps you from saying, hey, I also want to send a notification somewhere, or I want to send an email, or I want to shut down my device, or whatever else. So keep in mind that Fail2Ban is essentially a log to action mechanism, and the default action is just banning. In the most common case, it uses NF tables to just get stuff done. So how can I demo this? First of all, I created a very, very simple HTTP server in Python. HTTP in this context means really it's just listening on port 80 or whatever other port, HTTP style, and I can curl it and it gives me something back. When I curl it, it gives me something in a log. That's the stuff that I need. I really don't want to noodle about any kind of web framework or styling or whatever. It's really just about having one host connect to another host and this triggering an action. I'm going to show it live in a second, but as an example, you can see I curl my host, I get something back, This is the actual application. It just gives me a little bit of information on what happened, and it logs all of this. How can Fail2Ban react on it? Fail2Ban needs two things in the most common use case. It needs a jail. Jail is like the core glue code, let's call it like that, for a specific action. Because Fail2Ban, you only have one instance on your host. So Fail2Ban runs once, but it can protect SSH, it can protect your web server, it can protect your custom application, it can protect a lot of things, and each of those is a single jail. So for our demo application, we need a jail. This jail needs to be enabled, obviously. We need to say, hey, we are listening on which port, and you can see the filter equals fail. Fail is maybe bad choice of naming, but I called my my example application fail just because it fails to do something, or I want Fail2Ban to kick in. And we put the filter onto a log file at a known location. We define how many retries are allowed. We define the frame in which the failed attempts are allowed, and we define the ban time. Here, ban time is 1 minute, which is obviously not exactly useful for production purposes. But if I put in 1 hour, then we will spend 1 hour in the session waiting for better times to just demo the unbanning, which also happens automatically. And I felt that this is not really, really useful. So short ban time here. If you're using this in production, obviously make this longer. And this is how the filter looks like. You saw the log entry earlier. We will see it in real action in just a second. And as I pointed out, the key here is it's just a regular expression. The regular expression says like, hey, something blah 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 here, but find the IP at this point. This is why Fail2Ban has a magic constant called host. So you don't need to write an IP matcher. This means, hey, look for the IP here and whatever else beyond. And with that, let's try to actually use Fail2Ban. Remove this and add this. Great. I think we should take a real short peek at the actual code. So it's really just a simple logger, a handler for whatever arrives on HTTP, and it runs the server on port 8000 by default and on 0000, so I can access it from another host. This is really important, and you'll see in a second why. Okay, let's get this stuff up. Python fail py. Okay, server's running. Let's curl it. Localhost 80. Here it comes. So fail, just my application name, gives me back a little bit of information. We called from localhost. This is our user agent. This is the time, blah, 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 blah. Nice. Next thing we need to look at is the jail. JLD. I already showed you the screenshot. Just for clarification again, it's enabled. It sets a port. It sets a filter. It sets a log path, and so on and so on. And let's look at the filter for 1 second. Regular expression. Nothing is ignored. Yay, good to go. So install the filter. This is let's look at the script. So you see, it's really no magic here. It copies the failconf filter. It copies the failconf jail to etc fail2ban, the canonical directories. It reloads the application by restarting. It checks the status, and that's it. It's just a short script that I've created so I don't have to type all of this during the demo. And let's watch it. Oh, so you can see what I'm doing in the watch. It's literally just tailing fail2ban log. No magic here. It's just a little bit of convenience so you can watch what's going on. Did I do something wrong here? No, it's okay. So no failed attempts, no nothing, all is fine. So another attempt. And I would have expected to see a problem here now. Yeah. All is well. Okay. I said 5 attempts in 10 minutes. Let's get started here. Okay, so now you're saying, why does it still work? A lot of logs, a lot of stuff, nothing banned. Why is that? Anyone want to take a guess? Obviously not. So fail2ban by default does not ban localhost. This is something that I learned during preparation, all of this, that if you're trying to run all of this on the same host and you're always pulling localhost, it does not kick out itself. And that's why I have a second host here. Bam. Give it a bunch. Yay! And here it is. See? I did 5 requests and then failed to connect. Currently banned, 1. Banned IP list. This is my demo host. This is what I expected. So let's look at the watch. It's 10:23 at the moment. We can bubble a little bit for the next 1 minute. I will also finally link to the write-up I produced in this. So all of the demos, all of the demo code I'm using today, all of the configuration, all the stuff is explained in depth at this post. I will also drop it in the show notes on YouTube then. And that says, that is good until somebody has tunneled in. The key point here is, if they have tunneled in already, then fail2ban obviously failed at some other point in time. That's my take on it. But yeah, good point. So it's already 24 here. Let's check if it did already unban. See, total banned, but it's already unbanned again, and we can give it another try. So you see, the mechanisms are there. If somebody tries to hammer your application, fail2ban is able to kick in and keep them from doing that. And I think every connected device should have something like this to protect their open ports. Any other questions before I wrap up the demo for today? I'm going to give it like 30 seconds because there's a streaming delay usually. going once, going twice, as a beloved colleague of mine says. And yes, then we actually have another demo which did not explode. Yay. Full tutorial again. But I just realized that you don't have the slides, so you can't click the link. ESA says, can banning be based on any other criteria than the source IP? I don't think so. At least not by default, because the default action is to use NF tables. NF tables, to my understanding, does not have any insight into the user agent. What you could do is, if your application, I mean, it's on a higher level. If your application is layered, like having a front end stage, which does plausibility checks and ban listing and stuff like that, and after that, the actual application. So if your front end layer would have a mechanism to ingest data which user agents should be banned, then it could be done like this. So example, you have an application which drops IP plus user agent in the log. And then Fail2Ban detects numerous malicious attempts by a specific user agent. And then you don't use the default banning action, but you drop a kind of keyword of the user agent or pass it into your application's front end layer. Then the application could look at it. So that's what you could do if you want to ban a specific user agent. Another option is if you want to ban a specific, if you want to ban IPs only if they use a specific user agent. So example, you have 3 IPs connecting to you, but you only consider it malicious if they are not using a known user agent. And a known good user agent might be Chrome, for example. You only want to ban if they are using curl or wget or whatever. Then you could do this, because then it's a classic ban again. You just say my regex is not only the host, but it is also on not the user agent I expect, and then Fail2Ban kicks in and removes people through the table again. So it depends a bit on what you want to do. And thanks, Esa, for being around. I mean, you're basically my source of inspiration for a lot of the stuff that I'm doing here. I want to also provide a follow-up tutorial on how to put all of this together in Yocto. I just didn't want to do it here today because then I think it distracts from the core idea here. But I'll follow up with a tutorial on using Fail2Ban on Yocto. Watch out for it on the Manor Hub. And this will obviously use Sulka again because it gives me NF tables by default. And Michael says, sounds like a good way to ban AI agents. Yeah, and I kind of agree. The big problem is that AI agents often fake their user agent. And it's not really nice, but that's reality. Yeah. So my personal guess is that by triggering on the IP, you have more success, because AI is basically like a giant fuzzing mechanism when it hammers your devices. And it will try all kinds of combinations like user agent X, user agent Y, blah, 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 blah. But it will always come from the same IP, physically speaking. So, yes, user agent is an interesting idea, but I'm undecided if it's actually helpful. What should you take away? Fail2Ban is, as far as I can tell, really low impact because it really just requires NF tables to be around and Python 3. That's it. I mean, that's stuff that you should be able to get into most embedded systems, most embedded Linux systems these days. If you're super short on resources, then it doesn't apply to you. But I think this is possible for 99% of all use cases. And the interesting part about it is that it does not invent anything on top of the standard mechanisms. A lot of fancy security appliance companies, vendors, whatever, tell you, hey, we've got this super fancy agent which does all kinds of rainbow fart unicorn magic, and it's awesome. But you actually don't need this because there's NF tables in the Linux kernel, and you can just use it straight away with an automaton like Fail2Ban right on top. And the only thing that you need to really do is have your application provide logs that Fail2Ban can actually trigger on. It's that simple. And that's why what I say, this is what you should take away. If you have proper information, then you can act on it and you can use the standard mechanisms for this. Yes, I can rejoice again. Hopefully, we will see each other again in a month on November 13th. And I will talk about on-device multi-factor authentication. You can guess where I get my inspiration from. I promise I have a somewhat strange twist on it, how I think it could be used to protect a device that is really in the field. And let me know if you have any other questions, remarks, drop it in the comments, drop it on LinkedIn, drop it on YouTube. And thanks for staying with me and listening to my ideas on how we can make your devices more secure. So let me find my text to read out aloud. There is no next slide. Yes. So that's it for today's Device Dojo. Hit subscribe if you don't want to miss the next session and drop a comment below whether you've got questions about what we covered today or ideas for future episode. I'd love to hear from you. If you're ready to implement professional OTA updates in your own products, check out Mentor.io. All the links are in the description, and see you in the next episode. Michael says, Fail2Ban could be exploited by attackers to have legitimate text by spoofing their IP addresses. That is actually correct. I have nothing to add. That is a somewhat advanced scenario. And this is also why you should not have super long ban windows, but it is absolutely correct. Thank you, Michael, for this closing words, because I think it's a wise insight to understand each and every security measure can be used for good and also can be turned against the user. So use carefully. I would say thanks for watching me and see you around.